This is a lesson on some of the basic concepts and processes involving 2D or two-dimensional vectors. Array can be used to represent a vector, and the starting point of the array is called the tail of the vector, and the endpoint here, the tip where the arrow is called the head of the vector. We can name a vector using uppercase letters representing its endpoint. So say, for example, if this is A and that's B, then we can call this vector as vector AB. And we just use an arrow here on top to indicate the vector notation. A lowercase letter can also be used to represent a vector. So let's say lowercase a, but you have to put an arrow on top, and then you can call this vector as vector. You can call this vector as vector a, and then you just need to put that arrow there on top. There are alternative notations when you are using a lowercase letter to represent a vector, and one is using this symbol. So that's vector A with that little squiggly symbol there. Another way is to use a bold letter. And when you're using a bold letter, you don't need the arrow or the squiggly symbol on top. So you can just call this vector A in bold. Vectors are equal if they have the same length and the same direction. So for example, if this is vector A, this is vector B, and suppose A and B have equal or the same length, and the same direction, then we say that vector A is equal to vector B. On the other hand, if two vectors have the same length but their directions are opposite, uh, let's say this is vector C, this is vector D, and let's say that C and D, vectors C and D have the same length, but opposite directions. Then we say that they are opposites of each other. So we could say C is equal to negative D, or D is equal to negative C. Suppose we have vector A here, and we want to add, there is a vector B that we would like to add to vector B. What we need to do is to put the tail of vector B to the head of vector A. So let's say that this is vector B. The vector connecting the tail of vector A to the head of vector B, this vector, this is called the resultant vector, or the sum of the two vectors A plus B, or the sum vector, or more appropriately, it's called the resultant vector. As for vector subtraction, remember that when you're adding two quantities, you could express it as, when you're subtracting two quantities, you could actually express it as the sum of the negative of the other. So in terms of vectors, when, let's say, you are subtracting vector b from vector a, it's actually the same as a plus negative b. So what we do when you're subtracting vectors is a and b would then be, if this here is positive v, the negative b would that just be that vector with the same length as it, but it going in the opposite direction. So if this is negative b, then this vector here, that is your a plus negative b, or a minus b. Let's apply the vector addition and subtraction processes that we have just described into this situation. So you have this figure here, and for letter A, you want to find a single vector representing BC and CA, BC plus CA. So BC is right here. Again, remember that direction is important, so BC means start from B and go to C. That's BC. Plus CA. Start from C and end with A. The sum of those two vectors is the vector connecting the tail of the first vector and the head of the second vector. So this is actually the sum, or the resultant vector. So BC plus CA is equal to BA. Again, direction is important, so order of the letters, order of the endpoints are important, so BA is not the same as AB. Now notice that the resultant vector here, notice that this point, that letter, is actually just this, and this is just this. But that only happens because these two are the same. Now let's see if the same pattern applies when we do letter B. So for letter B, we have BA. What is that here? BA plus AE. So from A to E, plus EC. EC is here. The sum will be the vector connecting the starting point of the first vector to the tail of the first vector to the head of the last vector. So that will be, this will be the sum. It means that the sum, the resultant vector is BC. Again, it must be BC, not CB. And again, notice here that for your answer, B is the starting letter here, and C is the end letter here. Also notice that these two are the same, and these two are the same. Now pause the video and do C and D, and resume it when you're done to check your answers. So for C, we have AB plus BC plus CA. What's happening there is you're actually back to the original position. So we take this answer as 0. So when we have AB plus AB plus BC plus CA, so it's equal to, if you look at if you use the pattern that we had a while ago, the answer will be A and then back to A. That is actually what we call as the 0 vector. For D, let's see, AB is here, and we have BC, and we have CD, and we have DE. So the sum will be the vector connecting the tail of the first vector and the head of the last vector. So it's this. That's the sum. So for D, the answer is AE. So again, the pattern is your answer here. The A comes from this, and the E is here. And notice that that's B. Those are both B. These are both C, and these are both D. Now let's try this other situation. Here we are to construct or make vector equations for each situation. So for letter A, we just need to look for two vectors that have the head-tail connection, and then the sum of those two vectors being the tail of the first vector and the head of the second vector. So actually, if you look at R and S is connected to, the tail of S is connected to the head of R. And if you look at T connects the tail of vector R and the head of vector S. So the equation here is R plus S equals T. For letter B, I think there's more than one possibility here. P and Q do not have the head-tail connection, but if I do this and call this as negative P, and then Q is now connected to the tail of Q is now connected to the head of negative P, and this vector R then will be the sum. So that is negative P plus Q is equal to R, which you could write as Q minus P is equal to R. The other possibility would be say if we use this, or we could use this, P plus R, but then the sum will be negative Q. So another possibility there is P plus R equals negative Q. Now there are still other possibilities, but let's move on to C. I would like you to pause the video and do C, then resume the video when you're done to check your answer. There's also more than one answer for C. One would be to do G plus F plus negative E plus negative, and then the sum would be D. So let's write that G plus F plus negative E would be minus E. That would be equal to D. D, not negative D, because the sum connects the tail of the first vector to the head of the last vector. Now pause the video and do these exercises and resume when you're done to check your answers. So for A here, RS is here. So we could actually do negative r plus s. That will be your rs. So rs is equal to negative r plus s. Or you could write it as s minus r. Letter B, SR. Well, if RS is equal to S minus R, that was our answer in A, then SR must just be R minus S. And if you draw it, that's actually, this is negative S. This is R, and this is your SR. For letter C, ST is here. So that would just be, ST would just be negative S plus T. That's ST. So ST is equal to negative S plus T, or you can write it as T minus S. Let's go back to a little bit to naming or identifying vectors. Suppose we have this vector and we name it or identify it as vector A. We can make the vector identification more specific using what we call as the components of that vector. What it is, it's just when you move from the tail of the vector, when we move from the tail of a vector to the head using only horizontal movement and vertical movement, and in particular using the horizontal movement first, then the vertical movement. Then we have in here, this will be the, we move this way, this, and then that. So in this case, we call the horizontal move as the horizontal, we call the length of the horizontal move as the horizontal components. In this case, the length is 1, 2, 3, 4. So the horizontal component of the vector is 4, and the vertical component is 1, 2, 3, 4, 5, 6. So in vector notation, we write it as A is equal to, we use these brackets, this is the horizontal component, and this is the vertical component. In this vector, let's say that this is vector B, the horizontal component is 1, 2, 3, 4, 5. The vertical component is 3. So B is equal to 3, 5. Now remember that direction is important with vectors. And notice here that for our horizontal component, both our horizontal components and vertical components are positive, because the horizontal component from here, from the tail of the vector, we move to the right. So a move to the right is positive, and a move to the left will be negative. For the vertical components, an upward move is positive and a downward move is negative. In this example, let's say that this is vector C. Again, we start with the horizontal move and then the vertical move, starting from the tail to the head. So from the tail, if we want to go to the head using horizontal move first and then vertical, then we have to do this and then that. So it means that this is a negative 3 and this is going up. 1, 2, 3 is a positive 3. So vector C is equal to negative 3, 3. So when we identify a vector using its horizontal and vertical components, we say, like here, the horizontal component is 1, 2, 3, 4, 5, positive 5. The vertical component is positive 3. So when we identify a vector using its horizontal component and its positive component, then we say that in this case the vector is in component form. There is another way in which vectors could be expressed, and that way is called the unit vector form. Before that, what do we mean by a unit vector? It simply means a vector whose length is 1 unit. So for example, if this is vector A and the length of vector A is 1, then it's a unit vector. This is vector B and the length of the vector is 1, then it's a unit vector. Or you could go this way. As long as the length is 1 unit, then it is a unit vector. So how do we write the unit vector form of this vector, vector A, whose component form is 5, 3? The unit vector form, we will still be using the horizontal and the vertical components, only that we express it in terms of a unit vector. So here, for example, we start with the horizontal component as usual, and notice that for the horizontal component, there are 1, 2, 3, 4, 5 unit vectors. Each unit vector, as a general as a convention, the horizontal unit vectors, we usually use I for them. So there are 1, 2, 3, 4, 5 I's, 5 horizontal vectors. So we could call A as it has 5 I's, 5 horizontal unit vectors. And also it has 1, 2, 3 vertical unit vectors. And the vertical unit vectors, as a convention, they are called the letter J. Lowercase j is used for them. So we have 3 J's. Now notice that if you look at it from the adding vectors perspective, do you notice that the vector A is actually the sum of its horizontal component and its vertical component? So this is why A, we write A as 5i plus 3j. So this is the component form of the vector A, and this is the unit vector form of the vector A. Now, when adding or subtracting vectors in component form, you simply add or subtract their corresponding components. So, for example, in this case, vector A plus vector B would be 4, 5 plus 3, negative 2. And the sum will just be 4 plus 3, which is 7, and 5 plus negative 2, which is 3. And for the difference, A minus B will be 4, 5 minus 3, negative 2, And that would just be 4 minus 3 is 1, 5 minus negative 2 is 7. The process is similar when adding or subtracting vectors in unit vector form. So in this case, A plus B would just be 5i plus 7j plus I minus 2j, and that is just 5i plus I is 6i, and 7j plus negative 2j is just 5j. For subtraction, vector A minus vector B would be 5i plus 7j minus I minus 2j. That would be equal to 5i minus I is 4i, 7j minus negative 2j is positive 9j.